Okay, welcome everyone. Welcome. This is the week 6 webinar. So we are halfway through. So when we're done with this week, there'll be one half more week left, 6 more weeks left, and then we'll be finished with the class. So hopefully you'll make it through. And don't expect to like get everything done in the very last week of class. Make sure that you work every week. This isn't like some classes where there's a final exam that covers like 80% of the grade or something. This is each week is almost about the same. So as always, I like to talk about what the plan is today. And as always, I'll answer any questions if you have questions. And just to let you know, thank you for submitting your projects. I have started grading them, but it takes time. And I graded the discussion post first, but it does take me time because it's hundreds of pages of reading for me to do. Okay, depending on how long they are, but it takes a long time, and I write comments throughout. I want to let you know that um, whoever sent it or posted it, if more than one of you posted it, but that wasn't supposed to happen. But if you did, I just go alphabetical. So whoever's first in the alphabet, that's the one I read. And then I put a lot of comments on and make sure that if you have partners, hopefully y'all have partners, that you share the comments that I put directly on your paper to your partners because they can't see the direct comments, but they can hear you talk about them. So that is kind of important as we go. I will almost certainly have them finished by Wednesday, maybe even tomorrow, but definitely by Wednesday because I'm about 40% of the way through right now, and they do take time. So I do it by section and alphabetical is kind of how I do it. So just let you know the projects are, they're due. There will be a project too. It's a little early to even get into that. So other than, just relax a little bit for a week in terms of projects. And then next week we'll start talking a little bit about the projects. So what we're doing this week is confidence intervals. Confidence intervals are a very important application. Just to let you know, for the entire rest of this class, pretty much all we do is applications. Okay. Whereas like last week we had the central limit theorem. It had some applications, but we called it a theorem and all that. We're done with regular theorems, and now it's how do we really look at statistics and kind of really understand if you have a sample, how do you use it to make predictions about the population? So we'll start out with a confidence interval for a population mean. So that's going to be really important because that's when the survey question is quantitative. Okay. And we'll talk about what that means even to say confidence interval, but we'll get there today. Then we'll talk about confidence intervals for population proportions. So same idea, but now if you have a yes, no type question, then how do you come up with a confidence interval? Okay, and confidence intervals, by the way, are kind of estimates, but estimates with a range. And we'll talk about what all that means. Then we'll talk about sample size for means. So we talked last time that you need a sample size. Who remembers for if you have means in order to use the central limit theorem and do calculations? How big a sample size do you need? You can pop in the chat box. Hopefully you all remember. Yeah, you need over 30. So 31 is fine, 100 is fine. But that's okay. And that means that you can do the calculations. One problem with it is you may end up having a sample size of 31, but you may not be happy with how good your estimate might be. And we'll talk about that. So we're going to say, well, if you want to be, really confident about your sample being close to the population, then how many people do you need to survey? Okay. How many data values do you need? Then we'll do the same thing for proportions. So again, it turns out that was more complicated for the central limit theorem. You need NP and NQ greater than 30. But it turns out, just like with means, it's more complicated than that because you want to say, well, how good an estimate do you want? Okay. And again, by the end of this webinar, we'll have that down. So that's the plan for today. I want to remind you, this is week 6. What's important about the number 6 for this class? Yeah, 6 is an even number, so you have an exam this week. Okay. And I just want to give you a heads up. I I would not give you a project on an even week because that'd be too much for y'all to do in one week. So week 5 was your project, and now we're moving to week 6, and now you have the exam. Next week is kind of an easier week. No exam, no project. Okay, which kind of makes it easier. Um, but just to let you know that you do have an exam, and same as the others with the week 6 exam, there'll be questions from chapter all the way through from chapter 1 all the way up to this week. And this week is chapter 8. So make sure that you keep that in your head, all the different things we've done. But there is a larger emphasis on chapter 7 and 8 because that's our newer stuff. That's since the last exam. And in particular, word problems where you have to answer with sentences. Those are going to be week 7 and 8. So that is the plan. Are there any questions about anything? Always happy to answer, and I want to help you out. Any questions? Is a cumulative final? Yeah, all exams are timed, 90 minutes each. And just let you know, the cumulative final isn't even worth any more than your exam this week. So it's not one to like have a huge pressure on, but it means you need to work hard for every exam and learn all the stuff every time instead of just wait till the last 2 weeks of the class or last week of the class and then now I'll start. Make sure that you keep working and you keep learning this stuff. So because it's too late in the last week to move your grade that much up. You can go a little bit, a percent or two, but not too much. Does that make sense? Yeah, so all exams are timed. All exams are timed, and none of the chapter assignments are timed other than the Sunday night due date, is how it works. Any other questions? Good question. Okay, if there's no questions, I have a question for you. This is actually something I ask every time I teach this class. I've been asking this for the last, wow, it feels scary now, but 29 years. Because I've been teaching this forever. And here is a question. I've been watching it change, actually. How old were you when you experienced your first passionate kiss? Okay. And by the way, if you've never had a passionate kiss, just state your age. And I want to let you know that one thing is your name and answer don't get put onto YouTube, so don't worry about that. But if you don't want to tell everyone, just make a reasonable number up. Don't say, "Oh, I was 185," because that can't happen. Okay, so let's see if you can type in the chat box. This is very simple. How old were you? Okay, and I want you all to put it in because we want to put the numbers in. And I have to type as we go, 15, 17, 15. 15, 17, 15, 15, 16, 21. 27 and 12. Anyone else? Again, this is not a hard question. Okay. All right. Just let you know, by the way, I was 13. And everyone thought I was like really slow to get to it because in my day, things were a lot different. If you were 13 and hadn't kissed anyone, you were like a nerd. because that just was different, a different era. Um, and I've been watching it change actually over time. Okay, so here we go. How old were you? All right, so we have some data. Okay, and I'm gonna assume that our population is community college students because all of you are community college students. Sound good? So that's our population. We have a sample. By the way, is this sample size large enough to really trust what we're going to be doing? What do you think? Yeah, definitely not. But again, this is all I can do because we only get so many people to show up at the webinars, and we only have so many people in the class, actually, the classes. So we can't get large sample size out of this. But it's better than a sample size of two. So at least we can get something. So we're going to have to assume the distribution is normal. The population distribution of first passionate kiss, age is normal. Okay. And by the way, remember first three letters of assume. So it's an ass out of you and me. So it's a bad assumption. It's almost certainly not true, but we're just going to assume it. Okay. If you don't want to assume it, what do you have to do? If you had to conduct the study, hopefully you all know. Yeah, we have to ask at least 31 people, 31 students. Okay. And by the way, we're also assuming that there's no bias, which I actually have no idea with you all. I don't know you all. I mean, I see you on this, your names on the screen. That's about it. So I don't know what you're like. All right. So what I'm going to do first is I'm just going to take all this stuff. I'm going to go to the calculator. And just for now, I'm going to go to the one variable stats calculator. And this is a sample. And I hit calculate. And I get the mean is 17.25. That's X bar. The sample standard deviation is 4.68. Good enough. N is the sample size. That was 1, 2, 3, 4, 5, 6, 7, 8. Any questions so far? How do we get the standard error? Any ideas? One minus n? Not quite. Remember, we had the central limit theorem. And by the way, you don't need a large sample size for central limit theorem. You only need it for normal distribution, but you don't need it for getting the standard error. Do you remember how it works? The formula was the standard deviation over the square root of n. So I'm going to insert and somewhere. No, it's not a special character. Sorry, I'm losing it. It's math is what I want to insert, and they moved it on me. Sorry about that. Let me find it. Equation. Oh, maybe it's already in there. Oops. Get rid of it and put it back. Now we're going to insert equation. There, now it's showing it to me. And what we're going to do is we're going to have the standard deviation, which remember is sigma. And sigma is right over here. Divided by, and then square root of 8. All right. Do we know sigma? Do we know sigma? Do we know the population standard deviation? What do you think? I don't see y'all jumping in. Okay. We can't. There's no way you can know the population standard deviation of all California community college students the age of first passionate kiss. You just couldn't get that. So since we can't get it, what we're going to do is we're going to make an approximation. We're going to do our best guess. And our best guess, so let me do, I think it's this guy. There we go. Our best guess, need to go one over and then do it. There we go. Is going to be S over root 8, which is 4.68 over the square root of 8. Any questions on that? Okay. And I could pop that in a calculator, by the way. And we could say 4.68 divided by the square root of 8, and you get about 1.65 or so. Any questions? Any questions on finding all this information? All right, so now the next thing we're going to do is we're going to say, how do we, so we got all this stuff, which I just put in. We're going to draw a picture. Okay, we're assuming we have a normal distribution. Any questions so far about this picture? We have our X bar. Our X bar, pop it down a little lower. Our X bar is 17.25. Okay. Our standard error is approximately equal to 4.68 over root 8, which is 1.65. Okay. And what we want to do is we want to say, what's a range that we feel comfortable saying that the average age, the population mean age of first kiss lies between? Any questions on kind of the plan or the goal here? Okay, so we're going to say, well, it's not going to be exactly 17.25 because we just have a sample. So you can't get the exact population mean. But we can use our sample mean to make an estimate and say we're going to go a little left and go a little right, and it's going to be somewhere between those two numbers almost certainly. Does that make sense? Okay, so what we're going to do next is say, well, how confident do we want to be? Okay, because the idea is you're telling the world, hey, let's say you were, in the news and you're making a news article, and you want to say, hey, here's the population mean age of first kiss. It's between here and here. And I'm like 95% certain I'm right. Does that make sense? I might be wrong, but the probability of being right is 95%. Any questions on that idea? Any questions? Okay, so what you're going to do is you're going to draw this picture and you're going to say what value on the low side and what value on the high side will it be such that the probability is 0.95, given my mean and standard deviation. The mean of 4.6 of 17.25 and our standard error of 1.65. Any questions on this big goal? Any questions? I can get rid of this. Any questions on the goal? All right, so now that we have our goal, we can, if we want, use the normal distribution calculator and do that. But I want to show you an easier way. And I'm going to go back now. And what calculator and number do you think I want to use for the easier way? Not number 12 because we don't have a yes/no survey question. I didn't ask you, hey, have you ever kissed? It's not what I asked. I asked how old were you? Does that make sense? And proportions are the yes/no survey question. But it was a good try. So what do you think will be the right thing if we want a good guess for this, for age of first kiss? I don't see y'all jumping in. Hopefully you can figure this out. It's not a trick question. One hint is that last week and the week before, we did the normal probability, and I told you we do things in order at which the class goes. So it turns out we're on number 9 and 10, actually. And from the beginning, we had data. Okay. If you're given statistics, you click 9. If you're given data, which is what you guys gave me, I'm going to click 10. Confidence interval for a mean with data. Any questions on that so far? Okay, then what I do is I put my data in. Whoops. My data was over here. So don't forget to separate your data by commas. And I want to remind you, pretty much always in this class, if you have like a big number like 10,564, don't type in 10, comma 564. Just type in 10564. Otherwise, it'll have troubles. It'll get it wrong. And then I want a 95% confidence level. So here, notice it says, for example, for a 95% confidence level, enter 0.95 for CL. Okay, so it's really important to read the instructions. So I'm going to type in 0.95. Any questions on that? And the rest is really simple. And my calculator. Okay, so here's the picture. And now we have nice numbers. Okay, we have a lower bound and an upper bound. I think for this case, 1 decimal place is all you care about. I don't think anyone cares about 1/100th of a year in age. You might care about 1/10 of a year, but because like 13 and 13 and a half might feel a little different. But 1 decimal is probably enough. So in this case, 13.3 and 21.2. Any questions so far? So that's 13.3 and 21.2. Is that clear? Okay. Does calculator work for finding a percentile within a normal distribution? Well, that's not confidence intervals. That's what we did last week and the week before. Does that make sense, Amber? I can even show it to you if you want. We do it this way so I don't lose the data. If you get a normal distribution, and if you know the mean was, say, I don't know, 12, and the standard deviation was 3, and let's say we wanted an 80th percentile, then that's the probability is 0.8. And that would be a less than, and you hit calculate. So that's finding a percentile for a normal distribution. Does that make sense? Okay, we did that, before. Yeah, and hopefully you agree this is pretty easy. I mean, you have to type in the mean and standard deviation and whatever percentile you want, but there's not much here to do. You have to type in the information always. It doesn't read your brain. Okay, so just to note, sigma sub x bar is equal to sigma over root n. We didn't have sigma. We had to say, well, it was approximately 4.68 over root 8. Okay, but it's not. Okay, we're off. So this actually doesn't work if you use a normal distribution. And I know you would never guess this, but the kind of a lot has to do with beer. You're all thinking that. My guess is you have no idea why, right? Okay, and the reason is there was a long time ago, like 100 years ago or so, there was a brewer, okay, and they were doing confidence intervals and about figuring out beer. Okay, I don't even know all the details. I'm not a big beer drinker, and the person who was doing it realized that he wasn't right 95% of the time, and that's what he should be right 95% of the time. And that was because he was using this estimate, which is actually off by a little bit. Does that make sense? So he actually did some heavy, heavy math, which I'm not even going to like attempt to show you what it is, and came up with a new distribution called and what he did, he was also a professor. He was a professor and he worked in a brewery, and he named it after his students, and he called it the students T distribution. So that is what he used, and he showed that that really works. So the distribution we're using is, it turns out, not the normal distribution, but the student's T distribution, which takes the normal distribution and then adjusts it a little bit to handle the error of not knowing sigma. Okay, again, you don't have to understand the math at all, but I do want you to know that we're not using the normal distribution anymore. We're using the student's T distribution. Any questions on that little bit of, what's going on? And with this class, all you have to do is use your calculator and trust it. Sound good? It was my job to do a lot of coding. Okay, but I want you to know that we're not, we had to do an adjustment of the normal distribution. And it turns out the bigger the value of n is, the closer the student's T distribution is to being the same as the normal distribution. And it turns out if you take n and subtract 1, you call that degrees of freedom. And that's the word they'll use. And as you'll see that, because for every different degree of freedom, you get a different distribution. They're all called students T. But you say with n degrees of freedom. Any questions? All right, so now what we want to do is we want to interpret the confidence interval. Okay, and I strongly recommend getting paper and pencil when you're doing these and making sure that, or at least a typewriter, typing, that you can actually type out the interpretation, because I'm going to ask you to do that on the exam, by the way. So this week's exam, you're going to have to type it. I'm going to grade it. And I'm going to tell you there are certain things you have to have. So the first thing is it has to start with these exact words, but it won't always be 95%. 95% is the most common, and it's with. So I like to highlight the word with because that needs to be the first word. Okay? If I ask you to interpret the confidence interval and you don't have the word with as your first word, you will lose points. Got it? Okay, and I will let you know AI will not start with the word with. So that's one way I keep you from just using AI. So you should be glad you're listening to this webinar. If you ignore the webinars, then you're going to get lots of points taken off. So with 95% confidence, we can conclude that the population, okay, and I highlighted the word population. Another really important word, if I say it loud, it has to be there absolutely. Not just for this week, but pretty much for the rest of the whole quarter. If you're talking about a mean or a proportion and you don't refer to the population, I take off points. Got it? Or if you don't refer to the sample, if that's what it needs to refer to. Okay, now things are going to change a bit. Okay, or they're going to be about this. So again, don't just, use the template only. We're going to put in this population mean, because that's what we have, age of first kiss among, all right, so you see California Community College students is between 13.3 years old and 21.2 years old. All right, so I want to mention a few things. One, there is a template. Okay, but the other is you better be talking about whatever it's the mean of. So in this case, age of first kiss. Okay, and here are community college students, and it's years old. So don't just, memorize a template, which I'm about to show you, and just write that. Make sure you talk about what's going on. But the beginning is going to be the same words. This 95 could change. Any questions on what this tells you? By the way, do you think this gives enough information to really have a good idea of how old students are when they have their first kiss on average? What do you think? Right? If I told you, hey, I had my first kiss somewhere between 13.3 years old and 21.2 years old, do you know a lot about me? Or about this population? No, no, this is not very good because it's such a wide spread. Any idea how to make the spread not so wide if had time to do the study? What would you do? This is very important. We talked about last week, but now we can really refer to confidence intervals. Any thoughts? Yeah, you need more data. Okay. Our sample size is way too low. Okay. We're going to need a much bigger sample, not more than 30. More than 30 will make it so you don't have to assume you have a normal distribution. But if we want the kind of this in between thing to be really small, you may need more than 100. Do you see? And we'll talk later, towards the end of this webinar about how you actually do the calculation. Okay, more than 30 is the issue that I don't want to assume the distribution is normal. Does that make sense? All right, so now the next question is, what does it mean to be 95% confident? Okay, 95%, that's a probability of something. Does that make sense? Because here it was the area under the curve, that is a probability of being between here and here. And that's kind of the idea. So now let's go through and say, what does it mean to be 95% confident? Okay, and this is interpretation of the confidence level. I want to make sure that you hear the word, this is the interpretation of the confidence level. Got it? Okay, do not get confused between level and interval. Okay, if I ask you to interpret the confidence interval, that's very different than asking you to interpret the confidence level. So to interpret the confidence level, what does that 95% mean? And here's what it means. If many samples of sample size, and we had 8, so I'm going to put 8 here. Are taken, then each one will result in a different confidence interval. So if you asked 8 different college students how old were they when they had their first passionate kiss, Okay, you're not going to get this confidence interval. You're not going to get 13.3 and to 21.2. You get a different confidence interval because you ask different people. Is that clear? So every time you ask 8 people, you'll get a different confidence interval. Okay, so one thing you might want to say is, hey, do you think this confidence interval really does contain the true population mean? What do you think? Does it? Are we sure it contains the true population mean? Age of first kiss? Okay, and the answer is we're not sure. We're not sure. We're only 95% confident. So what we say is if many samples of size 8 are taken, then each one will result in a different confidence interval. 95% of these confidence intervals will contain the true population. Let me write down the keyword here. Mean age of first kiss. Notice it refers to what it's talking about, in this case, age of first kiss. The other 5% will not contain the population mean age of first kiss. Any questions on this idea? Okay, so kind of think about, let's suppose that, that was your job. Your job was to collect samples, find the confidence interval, and give it to the news. Then sometimes you're going to have a really good confidence interval that really does contain the true population mean. But other times you're not, even though you didn't do anything wrong. You just got bad luck and you asked the wrong people. But you didn't know. You don't know who's who. You're just randomly grabbing people or unbiased grabbing people. Does that make sense? So you will be correct 95% of the time that the true population mean is between there. And then 5% of the time you do these studies, you won't be correct. Okay. Do you think that's good enough, by the way, if you work for the news? If you work for the news media? What do you think? I don't hear you saying it. Okay. All right. You get away with it. Yeah. So for the news, it turns out that's the standard. Okay. That's the standard. And actually, it was a long time ago. I think about maybe 90 years ago or so. And it was standardized by the New York Times. That's who came up with it. It wasn't like statisticians. It was literally the New York Times. You might have heard of them. They used to be the main news media. That was before television even, and forget internet. So New York Times was the biggie, and they made 95% the standard. Okay. Does that mean you should always use 95%? What are the pros and cons of changing it? So I want to let you know in our class, we're going to have three standard confidence levels. 95% is the most standard. The lower confidence will be 90%, and the higher confidence will be 99%. Now, wouldn't it sounds like you'd rather be 99% confident, wouldn't you? What do you think? So what's the reason why we didn't decide on a 99% confidence level? Any thoughts? Why didn't we just go for the 99%? Any ideas? Okay, let me show you. I think the easiest way to do it is to just see it. The normal distribution is not the problem, actually. But if we go to 99 and I hit calculate, what just happened? Yeah, the range changes. All right. So now yeah, sure. I'm 99% confident that the average age of first kiss is between 11 and a half years old and 23.0 years old. Okay. But that's not useful. You could even, and that's silly. Do you see? Why does it do that? Because this 0.99 is the area between these two. So if we want the area to be bigger, we're going to have to spread it out more to get more of the area. Do you see how that works? If you, okay. If you want a 99, you're going to have to widen it out. If you want to narrow it in, then you're going to have to choose like 90%. And I calculate, and now I got much better, 14.1 to 20.4. Do you see how that works? Okay, and it's often that you can see in the picture what's going on. If you're okay with 90%, then you get a narrower range. And it's right in that area picture. What's the problem with going to 90%? We get a better range. We should be happier, right? Any thoughts? Okay, it doesn't include the data collected in the set. No, that's not the problem. The reason why the 90% is maybe not as good is that means you get a 10% chance of being wrong. Is that clear? So, for example, in medicine, in the medical field, not the news field, but the medical field, if being wrong is end up going to kill people because you're giving them bad medicine, are you okay with having a 10% chance of being wrong? Yeah, hopefully not. Okay. That'd be terrible. So then you might want to go to 99% or 99.99%. Does that make sense? Okay. On the other hand, there are some times when being wrong 10% is just okay. So, for example, when I invest in the stock market, if I'm right 90% of the time and wrong 10% of the time, I'm going to make money most of the time. Do you see that? Sometimes I'll lose some money. So that would be one, maybe 90% would make more sense. So it really fully depends on what the ramifications are. And by the way, the word ramification means the bad stuff that happens. So what the ramifications are of not having that mean being within your range. Does that make sense? Versus the issue of having such a wide range, you don't have much to say. Okay. If I went to 0.9999, I can, say, hey, the average age of first kiss is somewhere between -5 and 300. That tells you nothing about people, right? Because there's no people that's outside that range anyway. Of course, the average age of first kiss is in that range. Okay, so it's really important to understand when you want to use which. So the standard is 95%, but then you want to look at the pros and cons of moving it to zero point 0.9 or 0.99. Okay, and in your project, for example, project 2, you're going to have to do that. Any questions on this idea? Okay, just a template for the not for the conclusion. This is the confidence interval conclusion is with, maybe I'll make this bigger so you can see it a little better. With whatever confidence, and it might be 95% confidence, it can be concluded that the population mean whatever is between whatever and whatever. So that's a template, but make sure you put this stuff in. So age of first kiss is what happened in here, and this was between what did we have? 13.3 years old and 21.2 years old. Any questions on that? Okay. And then there's a template for interpreting the confidence level that I made. And again, don't just only write this, make sure you put it in the context. If many samples of whatever are taken, then each would produce its own confidence interval. And whatever your percent of these confidence intervals will contain the true population mean stuff, whatever that is. If I write XXX, don't put XXX. Make sure you talk about what it is. And whatever percent won't contain that true population mean. So that's a template that will help you in interpreting the confidence level because I'm going to ask you to do that. I want you to use our template or you lose points. Got it? So take notes. I don't post it, but remember it's going to be on YouTube. So yeah, it is posted. It's posted on YouTube. So you can always go back to it. Okay. And by the way, once it's posted, it takes a while to record and stuff. It takes like an hour, usually around an hour or so after the webinar is over. Go to YouTube and then you can find it. And you can find it. You don't have to go to youtube.com. You just go to the week 6 module and it'll say click here under the webinar. Okay. Of course, I can't put it up until it's done. So it will be, by the end of tonight. That make sense? Here's the first one. With whatever percent confidence, it can be concluded that the population mean, whatever you're talking about, is between whatever your number is for the lower bound and whatever your number is for the higher bound, and make sure you put what it's talking about there too. Okay, so it does help for templates. Just want to let you know this word mean is about to change. Any guess what it's about to change to in the next example? Yeah, proportion. Okay. And just note, we use the central limit theorem. So if you don't have over 30, you have to make that big assumption of normality, which is probably false. Okay, so now it's time to talk about proportions. And again, something I like always doing in these webinars, I like to bring in real stuff that is, going on. I actually found this today. So, this is not from last year. And what percent of all adult Americans think that Trump has done a good job so far this quarter? Okay. Any questions on the question? Can we find the exact percent? Is it possible? Can we find the exact percent of all Americans that think Trump has done a good job so far in this quarter? Can we find it? Okay. So your idea probably not is almost correct, but better is definitely not. There is no way you can find it because you would have to survey every American and have to get them all to answer your question. Okay, every adult American. And that's not going to happen. Okay, there's hundreds of millions of Americans. It's just not ever going to happen. Is that clear? Okay, so what we do instead, or what Gallup did, is they did a survey. Okay, and here's what they did. They did a survey. They asked 1,006 adult Americans, and they actually used stratified sampling. I'm not going to get into all the details because we've already learned that stuff. Now this is a yes/no question because the question was, do you think Trump has done a good job this quarter, so far this quarter? And your answer is, what do you think? Yeah, answer the question in the chat box. Do you think Trump has done a good job so far this quarter? Answer the question. It's not public, by the way. I'm not going to call your name out. Okay. So what I want to note is none of you gave me a number. None of you gave me a number. Okay. Okay. A lot of you said no. Okay. The other choice is yes. Do you see that? You either got to say yes or no. You're not going to say 37 or something. So this does not work for what we just did. Now we're talking proportions. And for pretty much everything we do from now on, you want to look, except for chapter 11, by the way, you're going to be looking at, is this a yes/no question, or is this a quantitative, give me a number question? Does that make sense? And this is definitely a yes/no question. All right, so p hat, which is the sample proportion, was 0.45. Okay, and that was in the article I read. So that came from Gallup. How do we find how many people said yes? How do we find how many people said yes? Let's see y'all jumping in. It's very simple. You take n times p. In this case, n times p hat. That's what we're going to use as our estimate. And n is 1006, and our p hat is 0.45. So I can jump to here and just go 1006 times 0.45. And I'm going to round because you can't have 0.7 people saying yes. So they clearly rounded. And I'm going to write 453. So NP is 453. And you better all know that 453 is definitely bigger than 5. NQ, okay, you could either do 0.55 times 1006. There's another way too, actually. You can do 1006 minus 453. Because if there were 453 yeses, then 1006 minus 453 will be the number of no's. Okay, and that will be 553. Okay, any questions on that? Okay, why am I even asking, are these bigger than 5? Why even bother asking, hey, are those numbers bigger than 5? What's the reason? Why did I ask that? Why do I even care? Because there's a big reason. I don't see y'all jumping in. Okay, let me tell you, because you need them to be bigger than 5 to be able to use the central limit theorem. Remember, with proportions, with yes/no answers, it's not about n greater than 30. It's about NP and NQ being bigger than 5. Is that clear? Okay, I will let you know if you use AI, it might tell you 10, and I'm going to take off points. In our class, we're going with 5. Okay, so stick with what we do. Okay, so now let's see if we can find the confidence interval. Let's go back. And let's see if you can tell me what we need to use to find the confidence interval that we want. What calculator number? Number 10, that's confidence interval for a mean, but we're not talking about means. Yeah, it's number 12 because we want a proportion. By the way, you click the wrong one, it's just going to be a mess for you. So it's really important to be able to read through. And I'm trying not to make this calculator tricky. I try to make it obvious in terms of the wording. Is it obvious to you now? Hopefully. We want a confidence interval for a proportion. And it asks you for n. That was 1006. It asks you for x. That was 453. It asks you for the confidence level. That was 0.95. Any questions so far? And a calculate. And there we have it. Okay. We have our lower bound, we have our upper bound, which by the way, this is much more decimals than you need. We can go to here, 0.420 to 0.481 if you want, or do rounding if you want. So 0.42 to 48, that might be better for in this case because it ends in small numbers anyway. 0.42 to 0.48 for the exam and for the exam and for the chapter assignments that are computer graded. Make sure you use what it tells you. If it tells you 4 decimals, use 4 decimals. Okay. And you can always use more, but you can't use fewer. Just let you know that. So 0.42 to 0.48. Any questions on that? Okay, I want to mention something else, and that is something called the margin of error. Okay, and this is going to work for means also, but I figured I didn't want to like overwhelm you. But the margin of error is how far the bounds are from the center. Our center was 0.45. Our bounds were 0.42 and 0.48. How far are the bounds from the center? What is the margin of error? See if you can tell me. This one you probably don't even need a calculator. You should be able to do this in your head. Most of you, at least. So what's the margin of error? How far are the bounds from the center? The center is always p hat, by the way, or x bar if you're talking about means. This is easy. Don't see y'all jumping in. Yeah, 0.03, because if you take 0.48 minus 0.45, you get 0.03. Right? 48 minus 45 is 3. Another way of thinking about it. And that's called the margin of error. You probably heard those words before. They're important. And it's kind of how much error do you have from your guess of being 0.45? Okay, with 95% confidence. Any questions on this idea? Not too terrible? Okay, let's interpret the confidence interval with a 95% confidence. So, what's the first word? Yeah, with 95% confident. We can conclude that the population proportion of all adult Americans who, and you go back here, think that Trump has done a good job so far in this quarter. In fact, I'm going to just copy and paste and then take away the question mark. And let's make the formatting the same. So population proportion of all adult Americans who think that Trump has done a good job so far in this quarter is between 0.42 and 0.48. Notice it has the word proportion, not mean. So don't make that mistake. That's a real common mistake that students make, is they confuse they just memorize a template and they write mean. But sometimes it's proportion, sometimes it's mean. Any questions on that? Okay, another way of saying it, so I did this already, is if many groups, for the confidence level, sorry, we can also say, let's put this in, with 95% confidence between, and we can turn it, sometimes it's easier to write as percents, 42% and 48% of all adult Americans think that Trump has done a good job so far this quarter. So that's a different way of saying it when you're doing proportions. Sometimes it's easier to tell people using the word percent than proportion because people understand that a little better. Okay. Any questions at all on that? Okay, now let's interpret the confidence level. So if many groups of 1,006 adult Americans are surveyed, then each group will result in its own confidence interval. 95% of these confidence intervals will contain the true population proportion of all adult Americans who think Trump has done a good job so far this term. Maybe I'll write and 5% of these confidence intervals will not contain, and I could just copy and paste. I love copy and paste. Believe it or not, in my lifetime, I remember when that came up. Copy paste. Okay. For you, my guess, I don't know how old y'all are, but my guess is that none of you were born. That was like one of the best things that ever happened to the computer. Any questions at all on interpreting the confidence level? Okay, I do want to give you a heads up, and that is these have a lot of words. Okay, they have a lot of words. So if you think you can write this with 2 or 3 words, you're wrong. Okay, you need to use kind of the template, and it's going to have lots of words. Any questions on that? Okay. I've actually had students say they had to do more writing in their stats class than in their English class. It's kind of weird, but there's a lot of writing in this class. Any questions so far? Okay. Just a note, I want to note the secret word is between. Okay, and giving you the secret word a little earlier this time. We still have a lot more to do. So that people don't just scroll to the end and hope for the secret word. So the secret word is between. We're kind of between, 2/3 of the way done. So we're between the beginning and end. Okay. And one reason is that when you talk about confidence intervals, you're 95% confident, and it could be 90% confident that the population mean and proportion is between these numbers. Does that make sense? So it's an important word. So that was the secret word. Okay, so now what I want to do is I want to talk about the sample size for the mean. So for example, we did this age of first kiss, right? And again, was 8 a big enough sample size to have a really good 95% confidence? No, it was terrible, right? We had this age between like 13 and 21 or so, okay, which tells you nothing. Do you agree? So the next question might be, how many people should you go and survey? Do you think you have to survey, 1 million people? 1 million students? Okay. Yeah, we don't need to survey 1 million people. Do you think 9 would be enough? That's bigger than 8. Yeah, probably not. Okay. So what we have to do is we have to decide how many we want. Okay. So I'm going to do that one first, and then I'll do another one after that, just for fun, since we've already talked about age of first kiss. So one thing is we're going to assume, okay, which isn't a terrible assumption because it's our best guess anyway, that our standard deviation is 4.68. Okay. So our standard deviation, so so S is equal to 4.68. And that is approximately equal to the sigma. So that's our best guess for sigma. So I'm going to give you a good notation so you can actually see it. All right. Any questions so far? All right. So how big a margin of error do you think you would be satisfied with? Right? We had a range that was like 8 or so. It was huge. So let's suppose if you wanted the margin of error to be no more than, how about half a year old? Okay, because you're probably okay with that. If you're within a half a year of your best guess for the, if you have a range of just a half a year on each side, that's like 1 year of width. Does that make sense? Half and a half. So if you want the margin of error to be no more than 0.5 years old, how large a sample size would you need? Any questions on that? Is that clear? All right, so I want to remind you here of the formulas. Sigma sub x bar is sigma over root n, right? And E, the margin of error, is your kind of your normal Z times sigma sub x bar, and that's Z sigma over root n. And now if you do the math, you get n equals Z sigma over E squared. That's the formula to find the sample size. Okay. And I want to tell you, I did something that made some people upset, but I've never had a student get upset from this. When I say people, I don't mean people, I meant other instructors. And that is the following. If I go back to the calculator menu, what calculator do you think I might need or I might want to use? Instead of doing that formula. Close, but we don't, but the survey question for the one we're doing is how old were you when you had your first kiss? And I was 13 years old. So that's not a yes, no question. Number 13 was sample size for proportion. So it's not number 13. You might have the right idea, just you read the wrong one. So what samples, what calculator number? Yeah, it's 11 because we want sample size for a mean. And all you have to do is you put sigma in. Sigma, remember, was 4.68. And that's our best guess for sigma. That's usually all you got as a guess. We want a margin of error of 0.5. And let's say you want a 0.95 confidence level. And I just hit calculate n. So do you agree that's easier than trying to use the formula and do the math and all that? Any guess on who might have gotten mad at me? All right, no one wants to guess it. There were some other professors that said that makes it too easy. And they wanted everyone to do all the algebra. So I'm saving you algebra. If you love algebra, you hate this calculator. Just let you know that. And the answer is 337. Okay, by the way, so again, over 30 is not, it's not just like 31. That's not enough. You're still going to have a very big margin of error. Yes, you don't have to make the assumption that the distribution is normal, but you'll have a big margin of error. So we need to survey 337. students. California community college students. Okay. By the way, that's pretty many. So sometimes you say, oh, maybe I'll rethink it because I don't want to spend the time surveying 337 students. Right? You'd be pissed at me if I told you had to do that for your project, right? Ask that many people. But there are some times when you need to. Okay, not for our class in terms of, project two or something, but in the real world, sometimes you have to survey a lot of people. Any questions on that? Let's do one more of these examples. Okay, let's suppose, make this a little bigger so you can see it better. Suppose you wanted to find a 95%, let's change it so we don't get stuck on 95 all the time. Let's suppose you wanted to find a 90% confidence interval for the population mean hourly wages of nurses in California. Okay, based on a preliminary study, the standard deviation is assumed to be $25 an hour. Okay. Okay. I think I'm going to change that because it's a lot more than that now. Let's go $75 an hour. They actually make a lot of money now. You want a margin of error of no more than, how about $2? How many nurses should you survey? Okay. So the good news is, now that we've done one example, should be really easy. Okay, all we do is we go back, this calculator. I'm going to hit refresh to just clear everything out. Our standard deviation was, oh, sorry, standard deviation is 25 was about right. That was my mistake. The mean wage might be 75, but our standard deviation is about $25 an hour. So our standard deviation is 25. Our margin of error, you're going to let it be 2. And the confidence level is 0.90. And if you hit calculate N. And we need to survey 423 nurses. Okay, which still be a lot of work to do in the real world. Okay, so don't just assume that over 30 is always fine. It's always fine for using the normal distribution when we're talking about means, but it's not always fine to get a small enough margin of error. Any questions on that? Any questions? Okay. By the way, this is not how much they make. This is the standard deviation of how much they make. Very different. Okay, if that makes sense. All right, so now let's say we wanted to find the sample size needed, but now we're not going to be talking about the mean anymore. We're going to be talking about a population proportion. And we want to find out how big a sample size you need. Okay, sometimes you have an estimate and sometimes you don't. Okay, by the way, if you don't have an estimate for sigma when you're talking about means, you actually can't even answer the question. It's not even possible. Okay, it turns out for proportions, if you have no estimate, you still can find the best, what sample size you need. So let's do another example. So it's going to two-part example. So suppose that you want to find the 99% confidence interval for the population proportion of cars in the United States that are electric vehicles. Okay. By the way, do you know the population of all cars in the United States that are electric? There's no way you would know. You can't find them all. Does that make sense? Okay. But what you can do is you can do a sample and get a confidence interval out of it. Let's suppose you want a margin of error of no more than 3%. How many cars must you look at? So do we have any idea, based on this question, the percentage of cars that are EV? Do we have any guess based on this? What do you think? Okay, for part A, it doesn't tell you at all about how many cars, what percentage of cars are electric vehicles. So we don't have a guess. We want a margin of error of no more than 3%, and we want a 99% confidence interval. So this calculator won't work. So let's go back to the calculator menu. And what calculator should I use? Which one? Yeah, number 13, because we want a sample size, but now it's a yes no question because, hey, is your car an electric vehicle? Yes or no. So I'm going to click sample size for proportion. And now it says, do you want no estimate for P or do you have an estimate for P? We don't have an estimate. So I click on that. Our margin of error, you want to be 0.03. One thing to note, and this is really important, is that it's 0.03. It's not 3. 3% is not 3 for the margin of error. It's 0.03. So it's one thing that people make mistakes on is that they forget to turn your percent into a decimal. We wanted a 99% confidence level. Okay, so that's 0.99. And hit calculate in. So I need to go and look at 1,844 cars. Any questions on how I solved that? 1,844. Okay. By the way, if I needed to do this without the calculator, it's actually really brutal. I'm not even going to try to explain it to you all. Okay, in fact, it uses calculus. I'm not going there. So use the calculator. It's really important. Okay, and by the way, I will know that using AI if you are using calculus. Okay, use the calculator. You're required to use our calculator. Okay, now let's look at part B. Let's suppose you looked at last year's data. And based on last year's data, 8% of all cars were electric vehicles. So now, how many cars would you need to look at for the 99% confidence interval? How is this different from what we just did? It is going to be the same calculator, but how is this different from what we just did? Yeah, now we have an estimate. So I'm going to click have an estimate. You'll notice this pops up, estimate for P. So now we need to put in our estimate, which was 8%, 0.08. Any questions on that? And then I hit calculate in. Now it's only 543. Huge difference, by the way. It turns out that if this percent is far from 50%, it makes a big difference. If it's close to 50%, it doesn't make much of a difference. And 8% is really far from 50%. So, if you had to do a survey of 1,844, that would take so long. 543 would take a while, but much less than 1844. Do y'all agree? So it's really important if you can get that estimate to get the estimate, because that'll save you lots of time. Any questions? Any questions on finding the sample size needed if you have this goal for a margin of error of no more than something and you have an estimate or don't have an estimate for a proportion or have a standard deviation for a mean? Any questions on the idea here and what the point is? Okay. It's very important because, hey, if I I could say, hey, if I did 20,000, then I'll get a better estimate. So why don't I just look at 20,000? What's the problem with that? Real world problem? Yeah, it's one of two things. Either it takes forever or it costs a lot of money. Yeah. Because 20,000, you're not even gonna do, you won't be able to have time for by yourself to do it, even if it was your full-time job. You got to hire a bunch of people. Does that make sense? So you want to have a good estimate on how many you need. And then once you have that estimate, once you know how many you need, then you're not going to waste your time. Is that clear? So this is actually a very important piece in the planning when you're conducting a survey, is you want to be able to say how many do I need to look at? So if it's for the mean, then what you typically do is you do a small sample size, maybe of 15 or something, and then take the standard deviation for those 15 you just looked at, and then use that as your estimate for the standard deviation. And that'll give you an idea of how many you need to survey. Is that clear? Okay, so the good news is we're at the bottom. So confidence intervals are very important. There aren't that many details to talk about. I mean, I could do more examples, but I did kind of each important example. And I just want to let you know that, it's really easy to change the confidence level and see what the confidence interval is to see if that works better for you. Does that make sense? It's really easy to go into the calculator. Okay, even for the project, it's a different calculator. It's just as easy. And change it instead of 99. What if you wanted 90? How long did that take? 3 seconds? Okay, so it's not hard to do that. And then you know your number. Okay, and similarly here, instead of 90, if you wanted 95, it took 2 seconds to do that. And then you can say, hey, what are the pros and cons of using a 95 instead of a 90 or a 99? And what you do is you say, well, 95, I got 13.3 to 21.2. 99, I got 11.5 to 23.0. So that's like way too wide. Maybe 90 might be better. Do you see how that works? And yeah, you get a 10% chance of being wrong, but now I got a much narrower interval. Maybe it's worth it. And you got to think about what you're doing and what the damage is going to be done if you get it wrong versus what the damage will be done if your interval's too wide. You see? So you can look at them all in seconds and make a decision. Any questions on that? Whereas surveying, 450 people would take forever, but changing the confidence level is seconds. Any questions on these ideas? Okay, if there are no questions, I want to remind you do have your exam this week. You do have this chapter to chapter 8 to do and the secret word quiz. And all that has to be done by Sunday, but I recommend doing it early. By Thursday, you'll have to do your discussion post. Don't wait till after Thursday, you lose points. And that's happening. Some people are doing that every time. Maybe you're not listening to the webinars, but don't lose points just because you're doing it on Saturday or Sunday instead. Do it by Thursday. Got it? And if you do it by Wednesday, then I'll give you feedback if there's anything to change, okay, for your initial post. So I want to give you the reminder of that. So I think I'm going to stop the recording. Thank you all for coming. And let's do that.